Hello. I'm audible.
Yes, sir. Good evening, sir.
Evening.
Yes, sir.
Evening to all of you. Okay, so today's session is about solve the of week 7. Okay, so let's wait for some for few minutes. Okay, so people are joining. After that, we'll start. So meanwhile, let me share my screen. Okay, then so that you can join the peer deck slides. Okay, on time. Okay, let me share my screen. Okay. Can you see my screen now? Is it visible?
Yes, sir.
Okay, yeah, fine.
Yes, sir.
Okay, so I'm hoping you are familiar how to join this peer deck slides. So please join it fast. Okay. Let me repeat the procedure for your convenience, and please do let me know if you are getting any difficulty to join this. So what you have to do, just enter joinpd.com on your browser, either on your phone or desktop, whatever you have right now. So if you enter joinpd.com on your browser, after that you have to enter the code. This code VUQJII. Okay. If you once you will enter this code, you will be directed to the slides, and you will be able to enter the answer through your system, and I will get the input from your side. Okay? Then we will be having some idea whether you are doing the questions correct or not. Okay.
Yes, sir.
Okay. Meanwhile, how is the week 7 content? Is it fine, moderate, or are you feeling it's difficult?
Sir, practice little bit difficult practices.
Okay. No problem. Try to solve more questions. Okay. The questions which you can do, and for below every question there will be solutions, right?
Yes, sir.
So what you can do, just first try to do on your own, then you can see the, after that you can cross check with the solution part. Okay. And there are TA session is going on. You can join and you can ask, or we have some platform discussion forum discourse and all. So you can ask there, will be answering there. Okay. Meanwhile, okay. So nine of you join this peer text, right? The rest of people please join it fast. Any one of you who is facing difficulty how to join this, or is it fine? Let me repeat the process. So what you do on your browser, just write joinpd.com. This thing which I have highlighted. If you write joinpd.com, after that you have to enter a code. So code is nothing but this VUQJII. So once you will enter this code, you will be able to, then you can see the questions on your screen, as well as you will be able to input the answers from your end. Okay. And I will see the input uh, which you have entered. Okay. So 11 of you joined. Nice. Let's wait for some 2 to 3 minutes, then we'll start the session. Okay. And everyone, please be ready with the pen and paper. Okay, so let me start, and the rest who have not joined it, please join it fast. So just enter on a browser, just enter joinpd.com, and after that you have to enter this code VUQJII. Okay, so you can join meantime. Okay, the now you code you can see on my top right corner. Okay, on my screen. So code is VUQJII. Okay, so and feel free to ask if you are facing any difficulty to join this. Fine. Oh, so this is for week 7. Okay, and this is something how to join and all as we have discussed. So I will assign some time limit for every question as per the level of the question. So you have to solve the question within that given time. Now, on right corner, below right corner, you will be seeing. I mean, you can see one green page where you have to enter the answer. No need to worry about the submission. Submission will be automatic. Okay, so this is some definition we have taken. So some definition of so some basic definition to introduce the probability. I mean, this is something which required for probability. So basic definition are nothing but so we have very first is random experiment. So random experiment is nothing but a random experiment is an experiment whose outcome is not predictable with certainty. Means we can't predict the exact outcome. Means we know the outcome. For example, suppose I'm saying you have to toss a coin. Okay, then you know outcome can be either head, either a tail, right? Yes or no? But you can't predict the exact outcome with certainty. Yes or no?
Yes, sir.
Okay. So those kind of experiment comes under the random experiment. If you see with the name random, we can't predict the outcome with certainty. Next definition is sample space. So sample space is a collection of all possible outcomes. All possible outcomes. So means for example, suppose you are going to toss a coin single time. Let's say I'm going to toss a coin. Okay. So if I will toss a coin, then I will get what is the collection of all the outcomes? Either I will get head or tail, right? So this is the sample space. Normally we are denoting sample space as S. Sometimes you can see some pi or omega, but here we are using S. Okay. But be clear with the concept. This is collection of all possible outcomes. Suppose I'm going to toss a coin 2 times. Okay. So if you see what we are doing, what are the possible outcomes can be? Both can be head, one tail, first tail, then head, then tail. These are the all possible outcomes. Yes or no? So this is the
Yes, sir.
sample space for this experiment. Fine. So sample space is nothing but collection of all possible outcomes of that experiment. Okay. Now events is nothing but outcomes or combination of outcomes that are I mean we are saying we are I mean we called as a event. I mean and it's that event is nothing but subset of the sample space. What do you mean by subset of sample space actually? Let's say I'm saying, suppose I'm saying I'm defining event A such that let's say I'm saying at least one head. Okay. So at least one head means what? It will be HT or HH or TH, right? Yes or no? Now you can
Yes,
say
sir.
this is nothing but subset of this S or not. Okay. So event is defined like this. Event is nothing but subset of your sample. Is this clear to all of you? Okay. Yes.
Yes.
Okay. And what is the subset? Subset is nothing but suppose I have two things A and B, two events A and B. Then if all the outcomes of A are also in B, then we'll say A is the subset of B. For example, here if you see here, let's define this is A. So if you see all the outcomes of A is in S, right? So I will say A is the subset of S. This is the notation. So here I will say A is a subset of S. It can be anything. For example, it can be like this TH, TT. Okay. Then what is this? This is the this. If you see all the I mean elements of this, let's say this is B. So all the elements of this event B is in this S, right? So I will say B is the subset of this. So this funda is clear.
Yes, sir.
So this is the very first question, which is very basic question to check your concept of random experiment. So there are three experiments: selecting a family out of a given group of families, selecting a card from a pack of playing cards, and rolling a die and noting down the number on the upper face of the die. So I'm going to give you some, I think, 3 minutes should be more than enough for this question. This is very basic question. You have to identify which option is the correct option. Means you have to check which one is the random experiment. So random experiment is what? Anyone?
An experiment that produces equally likely outcomes.
That is the random experiment. Okay, what we have discussed just a few seconds before. What is the
An
key element
experiment
to
that
identify
produces
it's a random experiment? Anyone?
Any outcome which is not predictable with certainty.
Correct. We can't predict the outcome with certainty, right? So just see and let me know which one is the correct. And those who have not joined it, this peer text slide, please join it. So what you do to just enter joinpd.com on the browser. After that, you have to enter this top right corner code, which you can see on my screen, BUQJII. Okay. Okay. So any one of you, do you need another time limit?
No, sir.
If you need extra time limit, feel free to ask. Okay. Okay. So let me see the responses from your end. So maximum of you are saying 14 of you are saying of some option number D and two are saying option B and C. Okay, so those who have selected B and C, why? I mean, why not A also? Feel free to say because we'll be able to know where you are
Sir,
liking.
excuse me,
Uh,
sir.
yes,
Sir, how to join this?
this peer deck.
Yes, sir.
Okay, so just enter joinpd.com on your browser. Okay, in your phone or in your desktop, whatever you have currently. After that, you have to enter a code. So code you can see on my top right corner screen. So it's VUQJII.
Okay. Okay, sir.
Fine. Yeah. Join it. If you are not able to do let me know. Okay. Fine. Okay. So those who selected B and C, can you let me know why you have not selected option A also?
Can I, sir?
Yeah, yeah, please, go ahead.
Sir, I selected B because, sir, here it represents selecting a card from a pack of playing card. So we have
Hmm.
a lot of card in that. From that card, we need to select one card. So
Okay.
that is a random experiment. We can select any card, but selecting a family out of
Hmm.
a given group of family, so we select only our family. So that's why A is not a random experiment. And for C,
Hmm.
rolling a dice, so when we roll a dice once time, so
Hmm.
whatever number I got, I just write on the that time. Here is no condition and no that thing, so it's not a random experiment. So that's why, sir.
Okay. Now, what about others? Those who selected all of the above. Can you correct him?
Excuse
Those
me,
who are
sir.
select. Yeah, yeah, please.
So, like for a random experiment,
Hmm.
we have to see like if an experiment is having more than one possible outcome,
Hmm.
then it is called a random experiment. So all
Uh,
these,
okay, okay. So it's about okay. So more than one outcome is fine. Thing that you have to observe one key thing, which is that you cannot predict the outcome with certainty. Means, for example, I told you, right? If you are tossing a coin, you know outcome can be either a head or a tail, right? You know outcome will be either head or tail, right? But
yeah,
can you predict which one will come exactly with certainty? Head will come or tail will come? No, right?
no, sir.
Correct.
Yeah,
Same thing. If I'm going to, let's come to the rolling a die. Suppose I'm going to roll a die. I know any outcome will be 1 to 6, right? Any outcome can be, right? Either 1 can be there, 2 can be there, 3 can be there, 4, 5, or 6, whatever, right? Any of the 6 will be there. But can you predict which one will be there? Can you predict with certainty? You are rolling a die and 2 will be there or 3 will be there? No, right?
No, sir.
Right? So this will be random experiment. Same, selecting a card from a pack of playing cards. Okay. Then see, there are collection of 52 cards, right? You can't predict which card will be there, correct? But you know any of the 52 will be there, correct? Yes or no? You know it can be king, it can be heart, it can be anything, but you can't predict with certainty. Same with the option number A. Suppose you have group of family, let's say 10 group of family. Okay. So you have to select a family. So I can do in 10C1 ways, right? But you don't know, you can't predict, right, with certainty which family you are going to select. Something which family we can do as per you can see compared to the option number B, right? So A is also a random experiment. Means you know any of the 10 family will be there, any one family will be there, but you can't predict with certainty. Okay. So actually all of the above is the correct option for this question. Is this clear?
yes, sir.
Fine. Okay, so let's move to the question number two. Question number two is saying after throwing of two dice, Ramesh gave you two statements. I mean, the following statements. Very first statement is there are five ways of getting the sum of numbers as five. Experiment is not a random experiment. Getting the sum of 12 is an event. Okay, so he gave these statements. You have to check which one statement is true. Okay, so I'm going to you some 3 minutes. Anyone? Do you need another time limit?
No, sir.
No, sir.
Okay, fine. Okay. So let me see the responses from your end. So all of you are saying statement number three is the correct. Okay. So any one of you can tell me why is that so? Why is the option? Okay. First of all, you let me know why option number two is not correct. I mean statement two.
Sir, it is a random experiment
Right? It's a random experiment. Why?
because
Because
we cannot predict the values. Like
Uh,
it can be
okay. How? Okay.
any
What is the
anywhere
total number?
between
How many total outcomes you will get if you roll a die two times?
36.
240.
36, right? And getting the okay, all of you have selected getting the sum of 12 is an event. Okay, then why is the correct? Why the by which definition this is the correct?
For an event 6, 6, the
Yeah,
sum
yeah,
Sir,
is
go ahead.
our sample space is 1112 up to 66. There
Uh,
and 6 is a element that will the sum of 6 and 6 is 12. So we are taking an event from sample.
okay, and we know event is nothing but this is just subset of your sample space, right? So okay, so very first statement was sum of should be five, right? If you see, so sum should be five, so it can be 1 4, right? 4 1, 2 3, and 3 2, right? Only these four, right? So there are only four ways in which I can get the sum as the five. But in the statement, Ramesh is saying it's a five ways, but this is the incorrect. No, experiment is not a random. This is also incorrect because we know a random experiment is what whose outcome we cannot predict with certainty. So here outcome will be total outcome will be 36, right? We cannot predict the any outcome with certainty, right? Next is getting sum of 12. So sum of 12 is what? Only 6 comma 6. Let's say this is A. So this is, so I can say A is nothing but subset of S, right? And we know event is nothing but this is a subset of my sample. Is this clear? Any doubt?
No, sir.
Okay. So we can see only statement 3 is the correct. Okay. So let's move to the next part of the question. This is the prelude 1 to question 3. So I think very basic question is there. Two unbiased dice are thrown. Find the probability that both the dice shows the same number. Okay. So you know what is the probability first of all? How we are defining probability? So probability is nothing but favorable cases, right?
By
Divide
two.
by total number of
Total
cases.
number of cases.
So by this question, okay. So I have given you 3 minutes. Just read the question and enter the answer. By this question means you have to favorable cases will be you have to count the number of cases where both die will show the same number. Divide by total cases. So what will be the total cases here?
36.
36.
36. Very good. Then we have to just see the we have to just count the number of cases where both die will show the same number. Okay. So just attempt it. You will see the response. Anyone do you need extra time, Louis?
No, sir.
Okay, fine. Okay, so let me say the responses from your end. Okay, some variations are there. 0.167, 0.166, 0.138, 0.16. Okay. So someone has entered 0.33, right? Why is that? Can you tell me the reason? How did you compute it? Any thought? Yes, no.
So as per my calculation, the answer is 0.166
Hmm.
because there are six cases where the board dice have a same number like
Hmm.
1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6.
Hmm.
And we have total 36 total cases. So 6 divided by 36, so we got 0.166. So that's my answer.
Actually,
Yes, sir.
one more
I
thing.
also thought.
It has mentioned enter the answer up to two decimal places. If you are getting 0.16 is right, so you have to enter 0.17. Okay, because it is more than 5. Okay, so we have to find probability of both die will show the same number. So we have to see the favorable case, right? Divided by total number of cases. So what do you mean by favorable cases? Means the cases where so this is our favorable event. So if you see when our both die will show the same number, so you have to see. So same number means 1 1, correct? 2 2, 3 3, 4 4, 5 5, and 6 6. Yes or no? These are the total possible favorable cases. These are 6. What is the total number of cases? 36, which is nothing but 1 by 6, which is nothing but 0.166. So if you approximate till 2 decimals, so I will say 0.1. Is this clear? Any doubt?
So it is necessary to round off the
Okay, if it
answer.
mentioned right, okay, it is mentioned in the exam during the exam, right, in the question
Mhm.
itself, then please round up because you will be providing some range. Okay, then
Okay.
your answer should be in that. Otherwise, someone has entered 0.16666, right? You can enter 0.16. So it will be random. I mean, answer will be random, right?
Yes.
So to get and some precise answer, accurate answer, we are mentioning you to enter two decimal places. Right?
Okay. Okay.
Okay. So this question is clear, right? Any doubt? I think this is a very basic question. Okay. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay, let's move to the next part of this question. Again, it's a very simple question. So two unbiased die are thrown. I mean, situation is the same. Question is the first die will show 6. Okay.
Sir,
So yes.
sir, unbiased means
Okay. So unbiased means let's say there is not any manipulation is there. Means suppose there is equal probability of getting all outcomes. Okay. So suppose I'm saying biased coin. I mean, suppose I have done some manipulation on the coin or something like that, such that I will get head all time. Something, I mean, probability of getting head is more as compared to tail. So that means so biased. You have done some biasness there. Unbiased means fair means there is, I mean, all the things are equal. Means suppose if you toss a coin, there is equal probability of getting a head, getting a tail. Okay, means half of. Suppose dice is unbiased means there is equal probability of getting one, means that is 1/6. There is equal chance of getting two, equal chance of getting three, four, five, and six. Okay. Suppose you have done some manipulation on the die, something like that, such that suppose you will roll a die and you will get maximum. I mean, there is higher probability for getting a six, something like that. Okay? That is something biased. Some rough ideas, okay?
okay. That means unbiased means that will get equally likely
Aha,
outcome.
yeah,
And
correct.
biased means not equally likely.
Yeah, not equal. Basic
Okay.
means fairness is there.
Okay. Fair enough.
So I've given you some 1 minute and do let me know if you need another time. So do you need extra time?
No, sir.
I received only 13 responses. Let me give you one more minute, and everyone please attempt it. Okay? So you'll gain some confidence, like you are able to do the question within the maybe in some fixed interval of time. Okay, so rather than entering answer on chat box, it's good if you join this peer deck labs and you are
Sir,
uh,
could you give some more time? I'm facing a technical issue.
okay, fine. Let me give you one more minute. Okay, so just let me repeat the procedure. So what you have to do, just enter joinpd.com on your browser. Okay. After that, you have to enter a code. So code you can see on my screen, just top right corner. You can see code is BUQJII. Okay. So let me see the responses from your end. So 0.17, 0.17, 0.17. समझ enter 0.028, 0.027. Okay, so 0.028, why? I mean, is there any reason? Yeah, please feel free to say so that we'll know where you are making mistake. Is there any, I mean, what was your approach basically?
Sir, my approach is, as the question says, the first die shows 6. So in the last row, we got 6 events, like 6 comma
Hmm.
1, 6 comma 2, till 6 comma 6. So in that event, first die is 6, and total outcomes are 36. So 6 by 36. So I got 1.16.
Okay, so 0.16. So, okay. What about those who entered 0.025, or I think it's 0.028. Sorry. Yeah, feel free to say. No one? See, only then we will be able to know what was your approach and where you are making mistake. Yes, no.
So I miss the in question it was written that first die. I miss that. I can consider six as a one outcome. So that's why I do 1/36.
Okay, no problem. Okay, so basically, if you see, so it's a very simple question. So it is mentioning the first die shows 6. So, okay, so if you see, what are the total? Okay, so favorable probability is nothing but favorable cases divided by total number of cases, right? So let me explain with the solution slide itself. So you can see we have total six favorable cases, right? Because first I saw six means 6 1, 6 2, 6 3, 6 4, 6 5, 6 6, right? So you can see in all these cases, first die is showing 6. And so these are the favorable case, and we know total number of cases is in our sample space is 36. Fine. So probability for this case will be 6 divided by 36, which is again nothing but 0.17. Okay. Is this clear? Any doubt? Is that fine, right?
Yes.
Okay, so let's move to the next part. So here, main question is there. So two unbiased die are thrown. Information the same. So we have to find the probability that total of the numbers on dice is greater than 8. Okay. So our favorable case is, I mean, we have to count the number of cases when total of the numbers should be greater than 8. So we have to count that cases, and like we know total number of cases is how much? 36, right? So we have to just divide those cases. So do it. I think I'm going to give you some 3 minutes. I think that should be more than enough. And do let me know if you need any extra time limit. Okay. Question is clear to all of you, right?
Yes, sir.
Fine. Yeah. Okay. Anyone? Do you need another time limit?
No,
Yes,
sir.
sir. Yes, sir.
1 minute will be enough.
Okay, sir.
Yeah. Okay, fine. So, okay, so Livansu is asking little bit hard question. Okay, so Livansu, this don't worry. So these questions is, I think, normally we are keeping the questions always slide, which are something similar to graded assignment. That's why we are conducting this kind of session just one day before of due date of graded assignment. Don't worry about level of questions. You can solve the questions in practice assignments and all. Yeah, sure, we'll take care of it and we'll try to come up with some, difficult problem. Okay. So let me see the responses from here. 0.36, 0.28, 0.28, 0.28, okay, 0.19, 0.11, 0.28. So 0.27, 0.28. This is the some similarity. Okay, so let's see the solution part. So actually, so we have to count the number of cases where some should be more than 8. So some should be more than 8. If we can see the there will be outcomes will be 3, 6, right? If you see sum is more than 8, right? 6, 3, sum is 9. 4, 5, sum is 9. 5, 4, sum is 9. 4, 6, 6, 4, 5, 5, 5, 6, 6, 5, 6, 6. So all these 10 cases, for all these, you can see sum is more than 8, right? It's strictly asking about more than 8, not greater or equal to 8 also. I think some of you have counted greater or equal to 8 or something. Maybe you have included
Uh,
8 also. Okay. Yeah, yeah, go ahead.
Sir, I have a confusion. Most of the time, I had a confusion in this. Ki
Hmm.
whenever we count such event, can we consider, for example, 4, 5 or 5, 4, both,
Hmm.
or we have to consider only individual event in
No,
such kind of questions?
both it will be different, right?
Uh, eh,
Because see,
Here they are
anyway.
saying
Hmm.
greater than 8,
Hmm.
right? So if we
Hmm.
add 4 plus 5 or 5 plus 4, both are
Hmm.
9, 9, right?
So okay, okay, okay. Let me ask you one thing. Suppose I'm saying, I define event as a something. I want to get 9. So to get 9, either it will be 4, 5 or 5, 4, right?
Right,
Okay. Suppose let me ask, what is the probability you will get 9? For example, just assume. So you will be at 4, 5, right?
right.
Or 5, 4, right? So what it means, you have to consider both, right? So this 9 I can get with this or with this. Anyway, we have to count both cases. Or similarly 6, 3 or 3, 6. Because you consider this as a separate, right? For example, so this means you are getting 6 on the first day, you are getting 3 on the second day, which is different. 3 on the first day, 6 on the second day.
Okay, sir.
Fine.
Yes.
So there will be total 6 cases. Sorry, total 10 cases. So favorable cases is 10 and total cases 36. So if you will divide, you will get the point. Okay. Is this clear? Any doubt?
No, sir.
Fine.
No,
Okay.
no.
Now, so some little bit tricky question is there. Okay. So probability of C is given to you. Probability of A union B is given to you, and probability of A union B means C is given to you. So you have to find what is the value of A union B intersection of C. Okay, a common hint is there to get an idea. Just consider A union B as a D. Then you will be able to know which formula you have to use. Okay, so I'm going to give you some 3 minutes, and we'll see how many of you attempted is the correct. Okay. Okay, so do you need extra time limit for this question?
Yes, sir.
1 minute or three?
One.
Okay, fine. Do let me know if you need another time. Anyone? Extra time limit, or is that fine?
That is fine, sir.
Fine.
Done, sir.
Okay. So let me see the responses. Point one, point one, point three, point one, point four. Okay, that's it. First of all, for this particular question, we have to apply one rule, right? That's called actually addition rule of probability. Okay. So what is that rule actually? Suppose I have two events A and B. So what addition rule says? So probability of A union B is nothing but probability of A plus probability of B minus probability of A intersection B. This is something addition rule. So how we are getting this? Okay, let's suppose this is the total sample space. Okay, and suppose this is event A and this is the event B. Suppose this is event A and since this is event B. So what will be A union B? Okay, first of all, suppose this is the one region one, for this is region two, or suppose this is region three. So what is the A union B? First of all, A union B means
A plus B.
uh
Remember that.
this all things, right? Total shaded region, right? Means I will say
Yes, sir.
probability of one plus probability of two plus probability of three, right? Yes or no? Something like that. Okay. So basically, what is the probability of one? Okay, forget about like this. Just consider if you see this one. So what we are doing, we are adding probability of A. This is total A, right? This red region, probability of A, right?
Yes,
Yes,
sir.
no, something like that. Okay. Now, and what is the B? So B is nothing but this green region, right? Yes or no?
Yes, sir.
So, but if you'll observe little bit carefully, so we are counting this middle part two times. Yes or no? Once for red and once for green, right?
Yes, sir.
Okay. So we have to subtract once this common part, right? This blue shaded. So this is formula came. So this is called addition rule of probability. So if you have probability of A union B, which is nothing but probability of A plus probability of B minus probability of A intersection B. So from where I can get probability of A intersection B as just a transformation of the terms. Probability of A plus probability of B minus probability of A union B. Yes or no? Correct?
Yes, sir.
So what are the information we have given? Probability of C is given to us 0.2. Okay. And A union B is 0.5. Okay. And uh, union of all this is zero point 0.6. So probability of A union B union C is nothing but 0.6. So if you see, if I will let D as A union B. So what are the things I have given? C as 0.2, probability of D as 0.5, then probability of D union C is 0.6, right? Yes or no? Because this A union B, I'm going to represent as D. So what is the things we have to calculate? A intersection B intersection C. That means probability of D intersection C. Yes or no?
Yes, sir.
Correct. So that means if you see this quantity, and this quantity is given to me, I have to calculate this intersection part. So by addition rule of probability, I can simply calculate probability of D intersection C. First of all, if I will apply D union C, so what will be the formula? Tell me. Probability of
Probability of D plus probability of C minus probability of D intersection C.
now. This is given to me. This is given to me. This things I have to calculate, right? So what will be? So I have to do the just transformation of the terms, right? So probability of D intersection C will be probability of D plus probability of C minus probability of D union C, which is very simple. So this is nothing but 0.5 plus 0.2 minus 0.6, which is nothing but 0.7 minus 0.6, which is 0.1. Is this clear? Any doubt?
No, sir. Can you explain it?
I mean, not clear or no doubt?
नहीं नहीं कुछ भी समझ में नहीं आया मुझे.
Okay, fine. So let me start. So first of all, tell me, this is the given to us, right?
Yes, sir.
This is also given to us. This is also given to us. Okay.
Yes.
So we have to calculate probability of A intersection B intersection C, right? So
Right.
I have just represented for our convenience D as A union B. Fine.
Hmm.
If D is a union B, that means we have been given probability of C is 0.2, D probability of D is 0.5, and probability of D union C is 0.6. So far, so good.
Yes, sir.
Now we have to calculate the probability of D intersection C. Yes or no?
Yes, sir.
Now we know what is the addition rule of probability. Probability of D union C nothing but probability of, let's make it D plus.
Sir, wait.
Hmm.
We have considered probability D union C is equals to 0.6.
Yes. Okay. Yeah.
D A union B.
See, this is given to me, right?
Yes, sir.
And I'm going to represent A union B as a D for
Ye-
the to so that we can relate with the formula. That's all. Okay.
Mhm.
So that means D union C is 0.6. Yes or no?
Sir, but how we can consider probability D union C, but like 0. Uh,
Hmm.
here given probability A union B, we are considered it as a D, right?
Hmm. Hmm.
So while calculating probability D union C, then where is the way we use 0.5?
Hmm.
Because if we are putting that in formula, then the value will get uh, to be changed,
How?
right?
Which value you are asking? This value?
Uh, not complete D. I
Hmm.
am saying if we
No,
are considering,
why it will change? Okay, suppose simply I'm saying probability of C is given to me. What is 0.2? Okay.
yes,
Then probability of A union B is given to me as point.
0.5,
Then I'm saying probability of A union B union C is given to me.
0.6.
Now I'm asking probability of A union B intersection C, right? Okay, I think
Yes.
it's a union B. No one has corrected. Okay, it's a
Yeah.
union B. Okay. Now I think that is something we have to calculate. Yeah, A union B. So if you see, can I, okay, for our simplicity, so that I can apply the formula, can I let A union B as a D?
Yes, sir.
Then probability of D is nothing but 0.5.
Yes, sir.
So same I'm saying A union B is the D. I'm just representing. This is just a notation. So can I say probability of D union C is 0.6? See, this A union B is same as
You
D.
simply just putting that
Ah,
notation in the formula, right?
correct,
Which is
correct.
probability D union C.
C. Okay.
Okay.
So here
Uh,
I have to find A union B intersection C. So it will be probability of, instead of A union B, I'm just keeping as D intersection C. Okay.
okay.
Now I have P of D, P of C, P of D union C. I have to calculate P of I mean probability of D
Okay.
intersection C, right?
Now, yeah. Now
Right?
we simply put the formula and
Uh,
calculate it in the.
you can go with this three also, not a problem at all. It's just for our simplicity. That's all.
Sir, what if we want to calculate from simply the putting things in that formula, like So the previous page, where you saw.
Just a minute. Let me connect with the charging. Yeah, fine. Where?
So
This
here,
one.
probably
Hmm?
no. In
Hmm?
the last one, Mm, the last one, down. Uh, Scroll down. Yeah, this one.
Hmm?
Probability A union B intersection probability C.
Hmm?
So is there any formula to put directly in this?
The value you are talking about, or you are talking about the
Directly a
hmm.
value.
No, no. Basically, this is something you can calculate with the formula itself. See, that's why I have just
So that thing I
hmm.
get that thing.
Hmm.
The approach you are doing is
Hmm.
completely understandable, but
Hmm.
I am saying
I mean, rather than D, can we use this directly, right?
yeah.
So fine, why not? See, suppose I'm saying probability of C is given to me 0.2. Probability of A union B is given to me as 0.5, right?
Right.
And probability of A union B union C is given to me as 0.6, right?
6.
I have to
Yes.
calculate probability of A union B intersection C, right?
Right, sir.
See, I had just substituted for our simplicity, that's all. See, I have to calculate these things, right? I know this is a single event, right? This is
Right.
given to me. Probability of a separate event given to me. I have given the union of these two, right?
Yes, sir.
I have to find the intersection. So I know this formula, okay?
Right.
Probability of A plus probability
Plus
of B
probability
minus probability of A
intersection B.
intersection B. Okay. Now probability of A intersection B I can find, yes or no?
Yes, sir. Yes, sir. A
Probability
plus
of A plus probability of B minus probability of
minus
A
A union
union B.
B.
Now, the only difference is instead of A, I
Mhm.
have A union B.
Okay.
If you see, observe, instead of A, I have A union B as a separate event. Intersection, intersection. Instead of B, I will C. So I will directly use probability of A. What is probability of A here? A union. What is B here? I mean, B means second event.
Second.
Minus probability of A, that means first event. Union B. Union
Mm.
C.
Mm.
Just keep the value. The same thing I have substituted with D. That's all.
So,
Fine.
Yeah,
my
okay, this.
approach is like this. The way you saw,
Hmm.
I did in this way.
So I
Okay.
also
So
thought like this only, but the previous one is quite easy. Yeah.
yeah, it is quite
That's
easy.
true. But I don't know why I
Actually,
follow.
this one is easy. So, because I mean, there is less probability of making mistake because
Mistake.
one will be able to easily identify the things, right? Here,
Right.
sometimes we can get confusion, which is the union, which is the intersection. That's why we are just
Just want
uh,
to confirm that I'm doing right or wrong.
no, no, it's
That's
right.
why
It's fine.
I.
It's fine. It's fine. See, this is something zero point 0.5, right? This is
Mm-hmm.
something zero point 0.2, and this is something zero point 0.6, which is zero point 0.1. That's all.
Thank you, sir.
Right? Yep.
Sir,
Yeah.
sir, in this question, like it was given that A union B complement then.
Yeah, that is the next question. Don't worry. Okay, so answer is point one. So next question is we have to find the complement of probability of A union B union C. Okay, so first of all, find this. Okay? So you have to find. So what is the complement of A union B union C? You have to think and solve it. Okay, so you can use the previous information if you. Okay, so I'm going to give you some 3 minutes. Do let me know if you need extra time. It shouldn't take that much time. It's very straightforward question. Just extra information is there, but you have to identify what is the things you have to calculate.
Sir, excuse me, sir.
Yes.
Sir, can I ask a doubt from extra activity, sir?
Okay, you can ask what is general, or else we can discuss
General
at.
only, general only.
Fine.
How to add a page in Google site. Actually, student portfolio has been created by me, but
So have you
I
seen?
need to add.
Have you watched that video by sir?
Sir, where is that video, sir, shared? It is
That's
not in
why.
your
That's
calendar.
why it's not in calendar. Actually, thing is that you should first of that's why we are providing everything. So you can see this extra activity for the course, right? So try to go through the right instruction video, and also you can find one video here, lecture video here, right? And one more video. You are from qualifier, right? So there will
Yes,
be
sir.
one lecture video, then another lecture video will be here. You can just see, and there is instruction slides for extra activity. From there, you can get an idea how to do that.
Sir,
Okay.
no, sir. In that only one student portfolio is there, sir.
I got
We are
your idea.
yes, sir.
Just, just,
Two
just
portfolios means how to
not
differentiate
to.
between them. Two extra activities are there, na, sir. So how to
Okay,
differentiate
so
between
that's why
them?
I'm asking. Have you seen this lecture video? No, right?
No, sir.
No. So just go through that. You'll get an idea. Okay, how to do it. Okay. If you click here, you'll directly go to that page.
Okay,
Okay.
okay, sir. Thank you.
Then you can see the ideas. So actually, this is something we are doing in stage 2 also. The similar thing you have to do for your course also, right? So you can get an idea, right? How to create and all. You can see. So it's a detailed video. Okay.
Sir, that is fine, sir. Actually, how to do and all.
Hmm.
But what my doubt is in first activity,
Then how to create for
what should be?
second, right?
Yes, sir. How to
The
create
same
for
thing I'm
second?
telling you, sir. Here you can see activity and all, right, on the left side. That's
Okay,
why I'm saying just go through this video. You will get the idea.
okay, sir. Okay,
Fine. Yeah.
thank you,
You
sir.
can see. You can see on left side. You will be able to see, right, classes and all. Okay.
Okay, sir. Thank you.
Right. Yeah. So there will be one more video if you're from qualified. Okay. Let me show you something. So there will be two things. So there is, you can see, so there is two lecture. One, yeah. So there is one this video by Andrew sir, and there is another refer the video, right? If you see these two, right, you will be able to then you can easily do the things. Okay. If you
Okay,
even though after this, if you are not getting the thing, do let us know. We'll see. Okay. Or you can raise
okay,
the okay. Fine.
okay, sir.
Can you
Yeah.
increase the time? So,
Okay. 1 minute or
20 seconds. 20.
okay. No problem. I have given some. Okay, so regarding okay, so if you are still facing any problem, you can ask to TA or you can ask in the. But I'm sure if you see that lecture video, it's a very short video. Then you will be having idea how to do that. Okay.
All right, thank you.
Yeah. Yeah. Thanks. Yeah. So I think this is very simple question, right? Or not? Okay, so let me see the responses from your end. Point four, point four, point four, point four. Okay, correct actually. Because the question is just about complement of A union B union C, and we know complement of A event is nothing but suppose E is an event, so probability of E complement is nothing but 1 minus probability of A. Here we have question is complement of A union B union C. So nothing but 1 minus probability of A union B union C. So 1 minus 0.6, which is nothing but point. I think this is very simple, right? Any doubt?
No, sir.
Okay.
No, sir.
So there, okay. So at the end of the session, we'll draw some Venn diagram and all, so that you will get some rough some idea how to identify the region and all. Okay. So let's do the questions from the slides first, then we'll do.
Okay.
Yeah. So yeah, this is the nice question. Here you to little bit be careful. Now you can use the video to identify where you want to use the permutation and combination and all. First of all, so forget about that. Okay, let's. So question is, an urn contains six white, four red, and nine black balls. So three balls we have to draw at random without replacement. We are not replacing. So find the probability that one is of each color. Means, I mean, one should be white, one should be red, one should be black. So to find the probability for that case, okay. So I'm going to give you some 3 minutes, and do let me know if you need another time.
Excuse me, sir.
Extra time limit? Anyone?
Yes.
Sir, without replacement means, I mean, suppose you draw one ball, right? Let me give you some 1 minute.
Yes, sir.
So then there is, I mean, suppose how many balls are there total? 19, right?
Yeah.
So suppose you draw one ball. I mean, then there will be how many remaining balls will be 18, right? Okay. So that is something without with replacement. You have to put again that ball in the box. Then again it will be 19. That is a with replacement. If you are drawing one ball, then
Okay.
again putting in the box again. But
Got
if you
it.
are not putting, then there will be remaining. Okay.
Yeah.
Yeah. Fine. Yeah. Okay. Do you need extra time? No? Fine.
Fine, sir.
Let me see the response. Someone entered 11.37. Okay, so is this possible? Probability can be more than one. Someone entered 81. I don't know why. Two. So it's a probability, right? So probability will always be between 0 and 1. It can't exceed value more than 1. Okay, so 281. I don't know how you have entered, but it's a wrong. So I think let me see again. This one, 0.22. So those who have entered 0.22, how is that? First of all, see if you see, we have 6 white, 4 red, and 9 black balls, right? So this is a box. So 6 white, 4 red, and 9 black balls. So we have to draw 3 balls without replacement. Okay. Now, so first of all, what we are defining probability is nothing but favorable cases divided by total cases, right? Yes or no? So total cases means what? We have to draw 3 balls. In how many ways we can draw 3 balls out of these 19 balls?
19C3.
Correct. So in 19 see 3 ways I can draw 3 balls. Yes or no? Okay.
Yes, sir.
So we have total cases 19C3. Yes or no? Now question is the balls should be one is from each color, means one from white, one from red, one from black. So in how many ways you can draw one ball? 6C1
6C1
and
multiplied
4C1
4C1.
and 9C1. So the value, whatever we can see, will see from the slides. So this is the correct answer. Is this clear? Hmm.
Sir, without replacement.
Mhm.
Sir, with replacement, if with replacement is their question, so what's the change?
Okay, you will tell me what is the favorite. Okay, so probability of all the ball should be one from each color, right? So what is
Right.
the total case then?
Total case will be 19.
19. Okay. In how many ways you can draw 3 balls?
One was.
Out of 19, how many? How you can draw three balls
Sorry,
in?
3 balls.
Hmm.
Out of 19, I have to choose 3 balls.
Hmm.
And each 3 balls have
Suppose you are doing with replacement. That is the something you are doing, right?
yes, sir.
So with replacement, okay. First of all, tell me. So probability one from each color, one from each. That means one ball is, let's say one is white, and probability one is red,
Right.
and probability one is
Black.
black, right? And you have 6, 4, and how many? 9,
4 and
right? So now, in how many ways you can draw one white ball?
6, choose one.
I'm asking. Okay, 6 to and probability. What is
Okay,
the probability?
probability.
Uh,
6 by 19.
Now you are doing with replacement means one ball you have drawn and you have seen it's a white, then you kept it again in the box, right? Again, what is the probability for drawing a red?
Got it, sir. Got it.
So it will be 4 by 19 and
Yes, sir.
it will be 9 by 19.
19.
While in the without replacement, what we are doing, basically see, actually it will be 6 by 19 into 4 by 18 into
18 and then 9
9
by
by
17.
17. But if you see, it's 3 factorial also, right? If you split there, it's 19 factorial, 3 factorial, 16 factorial. If you solve 19, 18, 17, 16 factorial, will get 10. It's the 3 from where 3 factorial it came.
Right, sir.
No, no. Tell me from where it will come. If you're doing without replacement, then it should be like this. From
It
where
should
we are
be first
So
of
dividing
all
by
we are
is
3.
white
choosing
or
one.
red.
Yeah, we are
Sorry?
choosing one by one from the 19 total 19.
थ्री
That's okay.
फैक्टोरियल वो है सर, जैसे पहली अगर
Okay,
लाइक दैट
suppose,
हो.
okay, we have done like this, right? 6C1, 4C1, 9C1 divided by 19C3. If you will solve this, you will get 6 into 4 into 9 divided by 19 factorial, 3 factorial, 16 factorial, right? If you solve this again, 19 into 18 into 17 into 16 factorial will get cancel out. Now you will be having 6 into 4 into 9 divided by 19 into 18 into 17 by 3 factorial, right? But my question is, if you are going, okay, this if you are doing with replacement, so this is the case. If you
Can
are
I
doing without replacement, so this should be case, right? Why this 3
Sir,
factorial came?
sir, could you please repeat again the
sir,
case
can I tell?
we are taking the with replacement?
So in with replacement, suppose with replacement, suppose you draw one ball, right? You have noted down the color of ball, then you are again putting back in the box. Means
Okay.
you are just replacing back. Okay.
Hmm.
Without replace means, so suppose you draw one white ball. So in how many way? What is the probability to draw one ball? 6 by 19, right?
Yes, sir.
Then if you doing the with replacement means you again
You again putting back
keep
the
box, then you will
yeah.
again 19 ball. You will again have 19 ball. Now what is the probability for drawing a red ball? It's a 4 by 90, right? Then 9 by 9. Fine.
Right,
So,
sir.
While
in the case when we
hmm,
are going with, without replacement, in that case we are dividing by that is total number of favorable events, count of favorable event to the
hmm,
total events. But in this case, we are taking like probability thing.
see, it will
He is
clear. Don't worry.
explaining
Don't worry.
how.
I'm doing in two ways. Okay, I'm doing in two ways. Okay, don't worry. So okay, this with replacement approach is okay. If
Yes,
suppose question is without replacement, then you will do 6 by 19, right?
one
Since
card.
it's without replacement, there is no need to put back in again in the box. Then
Yes,
you will be having 18 balls in the box, right?
right,
Then you have to, what is the probability for red ball? Then it will be 4 by 18, right? Then
right.
9 by 17. But if you do with the combination part, then there is one extra 3 factorial is coming out. So why is that so? Anyone?
Sir, just because it is the arrangement of that three walls. That is why it is coming.
Arrangement of 3 balls. Yes, because see, one
Yes,
red
sir.
ball is one white ball, one black ball, one red ball, right? This is the one of the case, right? So there will be lots of cases, right? It can be a red, black, white. It can be red, white, black, something like that, right? So these
Yes,
all things we can do in 3 factorial ways. Okay. So one way is you can, if it's without replacement, right? I can use the combination directly. Is this clear? Fine. Okay. So now you can see the solution in the solution itself. So it's nothing but 6C1. 6C1 means we are choosing one white ball out of 6 and 4C1 and 9. So answer is 0.22. So those who have entered 0.22, so 0.22 is the correct. Okay.
Sir,
Huh?
sir, I have a little confusion in when to take individual probabilities and use the multiplication rule and do like this.
See, multiplication
Like
rule means
sometimes.
if and is there, right? Then you have to take, see, suppose question is about you have to take one ball from each color, right? So that's why we emphasized on you guys probability and sorry, permutation and combination. You have to be just try to revise the concept of permutation and combination. So one ball from each color means one should be from white and one should be from black and one should be from red. So it's about and, so we have to multiply. Okay. If suppose or means one ball, it can be let's say white or black or red, then you have to add the probability of these cases. Got it?
No, sir. I mean,
Mhm.
when do we multiply individual property probabilities, or we have to take
That's why I'm
like
telling
this?
you, suppose there is a case where it's a and is there, right? Here one ball from each color. So one ball from each color means one should be from white and one should be from black and one should be from red, right? So it's and property and
Yeah.
means you have to multiply probability of white into probability of black into probability of red. Okay. If it's or means either one can be there, means union is there. For example, you have two things, two events A and B, right? And I'm asking what is the probability that A or B. And suppose this is the disjoint event. For example, just assume disjoint means probability of A intersection B is 0. So or means what? So probability of A plus probability of B. Okay. If it's something, let's say I'm saying you have two events. For example, this case and cases, you have to multiply the probability. Okay, so you have to clear with and you to be able to differentiate between and or these two. If this means you have to multiply and this is the case, you have to add. Fine. And we can add separately when events are disjoint. Disjoint means intersection. I mean there is nothing common. I mean common is 5. Fine.
Sir, that means even for this question, it
Mhm.
is same as taking individual probabilities and
And
multiplying
here
them.
is the multiplication. Yes.
It is same as 6C1 by 19 into 4C1 by 18 into 9C1 by
17, but we have to
17.
divide by 3 factorial also in the
Yeah,
denominator part because we can
yeah.
I mean here we are not worrying about the order, so we have to divide by those cases. Okay,
Mhm.
fine. Okay, so is that clear, right? So here next question is
Yeah.
I mean is that all right? Should we move to the next part? Yes or no?
My response is
Fine. Yes, no, anything, or should I go?
So one thing,
Hmm?
without replacement means we need to do combination.
Yes, yes, because see in combination what we are not worrying about the order. Okay.
Okay.
Fine. Okay, so can should we move to the next part? Yes, no,
Yes, sir.
fine. Okay. So next part is information is the same. There is a little bit change in the question. This question says find the probability that none is of red color. Okay. So none is of red color means what? What will be your favorable cases? First of all, see, you have to draw three balls, and so total cases will be 19C3. Yes or no? Now we have to
Yes.
worry about favorable cases. So what is the probability that none is of red color? None is of red color means no ball should be from red color. That means, yeah, that means what?
C1 into 4 C1.
Sorry,
So 6 C1 into 4 C1 by 19 C3.
why 4-7? Are you reading the question
So it's
carefully?
9 C1 and
Why 9-7? It's how many balls you are drawing?
So I will go with like 19 plus 6, that is 15. 15C3 for the new.
Correct,
Hmm.
correct. It's a very simple approach. See, there is no need to worry about red colors. It's simply clearly mentioned none is of from red color, right? That means we have to choose all three balls from white and black. That means how many balls are from white and black?
15.
15, right? So we have to choose any three. See, there is not any condition. Two should be white, one should be black, two should be black, one should be white. There is no condition. Basically, simply I have to choose three balls out of 15. Yes or no? Okay.
Yes, sir.
So I have given you the answer itself. Just calculate it and enter the answer. Okay? So I'm going to give you some. Let me give you some 1 minute. If you need extra time limit, just let me know. I think you need
So
extra time.
can you give
1 more minute or 3 minutes? Let me give you 3 minutes, okay? Just solve. Anyone? Do you need extra time?
No, sir.
Fine. Okay, so in the previous question itself, so you can see we have been divided by three factor, right? Just one uh, observation you can see. So basically it was about one from each color. So we got 6 by basically 6 into 4 into 9 divided by 19 into 18 into 17 divided by 3 factor, right? This is something you can do, or else you can do like this, right? 3 factorial into 6 by 19, 4 by 18 and 9 by 17. Yes or no? Okay, so this three factorial is just for arrangement of this case, right? Is this clear? Or you can think like, because it's about white, red, black. Okay, so there will be some arrangement, right? We can arrange these things, right? Yes or no? Because it
yes,
can
sir.
be blue, red, white, blue, something like that. So there will be. Okay. Okay, let's focus on this question. Let me see the answers. 0.22, 0.109, 0.47. Someone is, I think if you are entering something, right, so be clear with this, because as a statistical student, if you are entering value of any probability more than one, that means it's a very big mistake. So, anyway, it cannot exceed one. If you are getting value more than one, that means definitely you are making some mistake. Okay, so be clear with some basic thing. Okay, so it's a clearly thing. So here, if you see, I have 6 white, 4 red, and 9 black, right? 4 red and 9 black. So I have to draw 3 balls. So with the condition, none is of red color. Yes or no? So none is of red color means I have to basically I have to choose the three balls out of this 15, yes or no. So what will the
Yes, sir.
probability?
Yes,
What is
sir.
the total case? Total case I can choose three balls in out of 19 in 19 C three ways, right? So favorable case is shouldn't be any ball of red color, so it will be means I have to choose three balls out of 50. Is this clear?
Yes, sir.
Right? So answer is 0.47. If you solve this fraction 455 divided by 969, you'll get 0.47. Okay, is this clear, right? Just we have to be you have to just focus on the statement. Okay, is that all right?
Yes, sir.
Yes, sir.
Okay, let's move to the next part. If you see the question number 5, I mean, both were the sub part of these questions actually. So we have to find the probability that at least one ball is white. So at least one ball is white means what? What you are getting from this statement? Anyone? At least one ball is white means?
More than
If
one.
of the three balls drawn, I can have like one ball, two ball, or three, all three of the balls white.
Okay. That means you have to add some more cases.
Yeah, but there is a like turnaround. When we are given at
Huh.
least, we can consider a case that is total minus none.
Total minus none. Correct?
None. Yeah.
Or simply we can do at least no one minus none actually.
Mm,
Because none is complement of at least. See, I'm saying at least one ball is white. That means one ball can be white, two ball can be white, three ball can be white, right? I can
yeah.
simply say one minus probability of none. There is no ball of white color. That means correct. So no, none is complement of at least here. Are you getting?
Yes, sir.
Yeah.
So we
Yes,
can
sir.
simply now this is the very similar to previous question. Just one difference is you have to do one minus. If you do one minus probability of none is white, that means now what you have to do? You have to choose three balls out of. I'm talking about favorable cases.
Of 9 plus 4, that is 13. 13 choose.
13 because we don't have to consider the white ball, right? Yeah, correct. Okay, so let me give you some 3 minutes, then we'll discuss. Anyone? You need another time limit?
Still can you give me some time?
Sorry?
Add some time.
Okay, 1 minute?
30 seconds.
Okay, no problem. I have given. Okay, so should we see the responses or do you need
Yes,
another
sir.
time?
Yes.
Let me see. So I can see some differences. 0.29, 0.29, 0.705, 0.797. Okay, so those who have entered 0.29, they haven't subtracted the value. Okay, so we have to subtract with 1 minus because see total number of cases are 19 C3. That's okay. Question is probability of at least one ball is white. So it means I can simply do 1 minus probability that none of the three balls are white, right? Are you getting this? The second statement, this case. So at least one ball is white means see in that case you have to add all the cases means white, blue, red. Then it can be white, red, blue, white, white, red. All the cases we have to consider white, white, white till white, white. So it's a good, it's a very tedious task. If I'm saying probability of at least one, that way I can simply say probability one minus none is white, right? Yes or no? The same thing we
Yes,
have
sir.
done. So none of the three balls are white means we have to choose the three balls from red and black, correct? And how many red and black are we have? We have total 4 plus 9, we have 13 balls, which includes the red and black. So what will the probability of getting none is of white color? It will be 13C3 divided by 19C3, which is 0.29. So probability that at least one ball is white is nothing but 1 minus. Those who have simply written 0.29, so that's incorrect. So just you to focus with this minor mistake. So it will be 1 minus 0.29, which is nothing but 0.27. Is that clear? Any doubt?
No, sir.
Okay. So let's move to the next part. So this is question number 6. So just read the question carefully. Try to understand what are the things given to you.
Sir, can you
Uh,
explain the previous one?
okay. Where you are getting difficulty.
So 1 minus probability.
Okay. This is second statement is okay.
Yeah, no, sir.
Okay. So what is the probability? The probability at least one ball is white, right? See,
Yes, sir.
suppose I'm saying I have event A. Okay. And then A complement, I am denoting A complement. So what is the probability of A complement? Nothing
1
but 1
minus.
minus probability of A. Now here just assume. So I'm just saying, or else what you can say, probability of A is nothing but 1 minus probability of A complement. I mean vice versa, right? Suppose A is I'm defining as at least one ball is white. Okay. So at least one ball is white means what it will include? It can include white, black, red, right? White, white,
Yes.
red, and it will include all the cases: white, white, black, right? White, black, white, something white, red, white, something like that. All the cases, right? So I mean, there is a high chance you can miss the some cases. Yes or no? So I'm saying at least one is white. So can I do like this? Probability of A is nothing but one minus probability of A complement means at least one is white, then I will simply say 1 minus probability none is white.
Okay.
I can do or not?
Yes, sir.
Correct? The same thing we have done. Correct? So none is white means, because if you see at least one white, this includes a ball of white color, right? So I can simply do 1 minus complement of these things, right? So it will be 1 minus none of the three balls are white. So and we know how we can find none of three. None of three means none of three should be white means we have to choose three balls from red and black balls, which is nothing but 13C3. Is this clear now?
Yes, sir.
Fine. Okay. So next question is, I think, do you have any session from it?
Question, sir?
Do you have any session from 8 here?
Yes, sir.
Yes,
Mathematics?
sir. Yes, sir.
Okay, okay. Let's
Yes,
let's
sir.
let's try to solve the questions before time. Okay. So Suresh applies for a job in two firms, X and Y. Probability of is being selected in firm X is zero point 0.7 and being rejected. So be ready, be clear with this statement. Just a minor transform that manipulation is there. Being rejected at y is zero point 0.5, the probability of at least one of his application being rejected is 0.6. What do you mean by this? At least one is rejected. How will you denote in terms of notation? Okay, first of all, let's denote it. Form is selected as A. So what is given to us? 0.7. 0.7 is
So
probability
1
of A.
minus probability of the rejected one. At
1
least
minus.
one.
Okay, what do you mean by at least one? A union B, right?
Yes, sir.
Correct. So probability of at least one of his application being rejected means A complement
B.
union B complement. Yes or no?
A complement human B
See, at
complement.
least suppose you have two events. I'm saying at least one in any of the firm is selected. That means A union B is happening. Okay. I'm saying at least one of his application being rejected is A complement union B complement. Yes or no?
So I think I'm still not getting the this concept at
Okay.
least
Let me
one
let me
because
let me give you some ideas. Then because suppose it's saying Suresh applies for a job in two firms X and Y. Probability of being selected in firm X is zero point 0.7. So let's denote it for A. I'm denoting A as event A that is selected in X, right? Correct. Then A complement will be rejected,
yes, sir.
correct. Suppose B is selected in firm Y. That means B complement will be rejected.
Yes, sir.
How, okay, what is the meaning of A union B? Means selected in
A
at
X and Y.
basically I can simply say at least one of his application is selected, right? Yes or no? Then question is probability of at least one. I mean the things is given in the question. At least one of his
So
applications
here
is
we are
rejected.
taking as a either,
Correct.
right?
So at least one means A complement can be there. See A. See what
No,
is this A?
I just mean to say,
Hmm.
if we correlate the definition of A union B, we can take it at least as an either, so we cannot get
Yeah,
confused,
either A or B.
right? Either in
Hmm.
A or B or both, right? So here
Yeah,
they are
so that
saying at least.
that yeah, correct. That is something. It's defining A union B, right? A. So if you say A union B, this side we are considering A, we are considering B, we are considering this common also, right?
Yes, sir.
That's why we are treating this A union B. Got it?
Got it, sir.
So if he's saying at least one of the his application being rejected, so that means A complement union B complement, right? Yes or no?
At least one of his application is selected. Yes, sir.
Then for rejected, it will be a reverse order. Fine. So this is given to you as zero point 0.7 probability of this. Okay. So I'm going to give you 3 minutes and do let me know if you need another time. We have some six remaining slides. Okay, no problem. We'll do. So why we are doing A union B as at least? Because see, in A union B, okay, normally how we are defining A union B? I mean, it contains basically all the elements which are in A and B, right? That is something we are defining A union B, correct?
Yes, sir.
So that's why this is the interpretation of at one. Fine. Okay, so I've given you here. Just do the questions, solve the questions based on that information.
So for this particular question, we cannot we see it like this also? That
Hmm.
is complement of the case when both the applications are selected. That is complement of X intersection Y.
Hmm.
We can see that in the that way also, no? This question.
Complement of X
I'm
intersection.
saying X intersection Y ka whole complement.
That is the same thing. A complement union B complement.
Okay. Yeah, that is. Yeah, that is. But what came to my mind was it's saying that at least one of application being rejected.
Okay,
So
it's not about see. It's not about A intersection B whole complement. We are talking A okay, one second. I think you're talking about that De Morgan's law, right?
no. So
Uh,
what I'm saying is, the in the last sentence, the
hmm.
question says the probability of at least one of his application being rejected is
Correct.
6. Yeah. In that case, the only case that violate is when both my applications are being selected.
Selected. So
Else,
that is something we can do A intersection B whole complement actually.
yeah, that is
So
what I'm saying.
correct. So that actually that is the same as A complement union of B complement.
Yeah, but they consider De Morgan's law to bridge both these ideas.
Yeah. So
Mhm.
I will draw actually. That is something you can get an idea with the Venn diagram itself. Okay. Okay. I will give you just let's time end. I will. Do you need in the extra time limit for any this question?
Need to solve. I was just thinking about that.
Okay, no problem. 3 minutes will be more than enough. Okay, let me draw the Venn diagram now itself so that you can get the idea. Otherwise, no, there is not point to solve the questions. Okay. Suppose I'm saying I have two events, right? A and B. Correct? This is A. This is okay. Let me draw B little bit properly. Suppose this is the B. Try to understand here. So suppose here we are talking A intersection B whole complement. Okay, what is A intersection B? This one, this dotted region, right?
Yes,
Yes
sir.
or no? And what is the A intersection B complement is apart from this, right?
Yeah.
This line one, right?
A
This whole
intercept.
thing,
Yeah. This whole. Yeah.
correct?
Yeah.
Now let me draw another Venn diagram. This is A, this is B. Now I'm saying A complement. What is the A complement first of all?
A complement means outside
This,
the yeah.
correct? This green shaded region, correct?
Yeah. Yes, sir.
And what is the B complement?
Outside every region, all the region outside the second circle.
That is this red.
Yes, sir.
Yes or no?
Yeah.
If you observe carefully, this is the okay. This B complement is red, okay, and A complement is green. What is the union of these two?
The same that is
True false?
in the first
So
case.
now is it clear? This is same as A intersection B whole complement,
Yes, sir.
right? So that is something the case we are saying probability that at least one is uh, I mean in the one of the form is I mean his application is being rejected. So that means we can say probability of A intersection B whole complement, which is same as probability of A complement union B complement. Is this clear?
Yes, sir.
Okay. Now you can apply the formula. Okay. I'm going to give you some 3 minutes and do let me know if you need another time. Fine.
Yes, sir. Done, sir.
Okay, no problem. Let's wait for. We'll proceed after that. Next session has it started already, or is it? And it's for math one or math two?
So
Sir,
for both.
Okay.
Sir, actually, I have like two tutorials out from the this last seventh week. That is
Okay.
tutorial 4 and tutorial 7. If like at the end of session, if you could please explain.
Fine, fine, fine. We'll discuss.
Okay, thanks.
Yeah. Okay. So let's see the solution part. Okay. So suppose, yeah, the same thing we here it has been taken. So A and B, you can see the Suresh, when we are defining, Suresh is selected in form X and Y respectively. So probability of A is zero point 0.7. Then probability of A complement will be 1 minus zero point 0.7, which is zero point 0.3, right? So just do let me know if you need, if you want, I should write. If it is okay with this slides, then it's fine. Okay? Because we have to do one more question after this. That's it. So probability of B complement. So B complement is what? Being rejected at Y is zero point 0.5. So B complement. So B is nothing but being selected in Y. So being rejected will be B complement, which is zero point 0.5. Then probability of B will be 1 minus zero point 0.5, which is again zero point 0.5, right? Now, the another thing is probability of at least one of his application being rejected is zero point 0.6. That means probability of A complement union B complement is given to us. Actually, this is same as we have discussed. A intersection B whole complement. This is the interpretation of this one. So we know by the addition rule of probability, so it is zero point 0.6. So I can apply the addition rule of probability, which is nothing but probability of probability of A complement plus probability of B complement minus probability of A complement intersection B complement. Right? Yes or no? So far it is okay?
Yes, sir.
Correct? Now, if you see the question is probability of he will be selected in one of the form in X or Y. That is nothing but 1 minus, that is probability that A union B, right? And
Sir,
A is, yes,
for this, please, what I understood from this question was that either A or either B, that it was saying that B selected in one of the forms.
correct. So
So,
that is probability of A union B I need to compute. Correct?
it's a it's the case of either in one of the firms
Mhm.
or A union B thing. So that the thing could you help me differentiate a bit? Like, should we
Okay.
consider A union B or should we consider either A or either B? Like,
No, no, it's a union B. Okay, so if you're see here, it's a common thing. Either A or either B means you want probability of A plus probability of B, right? You mean this case, right? You are asking this case.
yeah.
So this will happen only when there is no intersection. But that's not the case here.
No, no,
Fine. Hmm.
and that also happens in the case when probability of A plus probability of B
Hmm.
minus probability of intersection thing. Then
Correct.
also
So
at that case also we can calculate the either case.
correct, correct,
Either,
correct. So but if you see, but we don't have probability of A intersection B here, right? Are you
A
getting my
intersection
point?
we can calculate. That's point 0.4. Like
See,
that's
probability of A union B I have to calculate, right? I
uh,
have
oh,
information.
so what my doubt is, it's
Hmm.
question is saying that he will be selected in one of the firms.
Hmm.
So how did we decide that it's asking for A union B? My only question is that.
Okay, okay. Tell me, how what? Okay, suppose A is something 1, 2, 3, correct, and B
Yeah.
is something 2, 3, 5. Okay,
Yeah.
what is the A union B meaning of
A union B means 2, 3, 1, 2, 3, and 5.
1, 2, 3, 5? So what
Yeah.
is this? The elements is in either A or B, right?
Yeah, in one
Hmm.
of the firms.
Correct? Basically, union of these two is nothing but we are considering a set containing all the elements which are in A and B. Correct? Which
No,
are
no.
in either A or in B. That is something.
Let me reframe my question. It's
Hmm.
saying that selected in one of the forms.
Hmm.
So does that means that I can also be selected in both the forms?
Okay, okay, I got
Uh,
it.
that is
Okay.
my doubt because yeah.
Okay, so if you see the same thing, right? If you two is here. Anyway, I have to take the unique, right?
So union thing
Hmm.
I know,
Hmm.
but my doubt is only with this thing. It's asking that selected in one of the forms. So in that case,
Hmm.
we are considering A union B
Okay,
means
you mean here it should be either A or B, right?
yeah. So
Ah,
I want to differentiate like why did we choose A union B instead
correct,
and
correct, correct. Correct, I got. I think we should reframe this. Yeah, actually, it should be something little, or it should be something at least A or B.
yeah.
Correct.
Because
Got
I
it.
calculated point 0.4 and that was I considered the case of either A or either B.
Fine, fine. I got
So
your
it's
point.
asking
Okay,
inserted in one of the forms
okay,
means
okay. No problem. We'll rephrase it. Okay, it should be either A or B or at least one of the form. Fine.
yeah.
Okay. Yeah. Yeah.
Thanks.
Correct. 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 Yeah. Okay. So as per this information, okay, till this third step, it is okay for everyone. Yes. No.
Yes, sir.
Okay. So next is probability. Okay. Okay. So our idea is now it's I think it's fine, right? Now here it is okay. Form X or Y, right? It should be either X or Y. So probability of A union B we have to calculate. So we know probability of A union B. I can do 1 minus probability of A union B complement or not. Yes, no? See, probability of A is nothing but 1 minus probability of A complement. Fine. So here we know by this Venn diagram or this one called De Morgan's law. So probability of A union B complement is whole complement is nothing but probability of A complement intersection B complement. Fine. And this probability of A complement intersection B complement we can find from this third equation, which is nothing but just transformation of this term. It will be probability of A complement plus probability of B complement minus probability of A complement union of probability of B complement. So it will be 1 minus 0.3 plus 0.5 minus 0.6. It will be 0.8. Is this clear? Any doubt in this particular question?
No,
Calculation
sir.
part is okay. Fine. What about this? This equation is okay. From where we got? Okay.
Sir,
Yes.
sir, can we use the De Morgan formula directly? Like what I did
Yeah.
was I have
Anyways, if De Morgan's law if you want to use, then you have to calculate this part. Okay. So De Morgan's law you can apply here in this part, but for this you have to apply the addition rule of probability. Fine. Is this clear to all of you?
I did in some other way.
Okay. How?
Like it is given P of um, A complement union B complement.
Mm-hmm.
I have applied that De Morgan formula directly. It's same as P of A intersection B complement whole
Oh.
complement.
Hmm.
That is same as 1 minus P of X intersection Y, which is given as zero point 0.6. Then I will get P of X intersection Y is equal to zero point 0.4, and it is given the P
No,
of
no.
B
See.
complement zero point 0.5.
Probability of
Then
A intersection B you have to then again you have to apply the addition rule in that part.
yeah,
Hmm. See, anyway,
again
if you want to apply the De Morgan's law and the third step, it's fine. We can apply the same thing and the fourth step also. Okay. Okay. So can we move to the next part? Any doubt in this question? Yes. No.
No,
Fine. Okay. Yeah. So So next question is, it's a little bit, it will take some 3 to 5 minutes. So question is, you have been given some five numbers and two alphabets which are to be placed next to each other for making a security password in a laptop. Question is, what is the probability that there are exactly two numbers between the two alphabets? Okay, so are you getting the meaning of the question? We have to identify exactly two numbers between the two alphabets. So first of all, okay, we have to use five numbers and two alphabets. What is the total arrangement?
That's like 5 factorial
Hmm?
and times 2 factorial. We are placing them like
Okay,
together.
basically, okay, just go with the condition. We have to, condition is there should be exactly two numbers between two alphabets. So in how many ways we can arrange two alphabets in the two places?
Okay.
Okay,
Just
first of all, take the numbers. In how many ways we can do?
Factorial.
Okay, so
So
first of all,
7C5
see,
into 7C2.
again, you are just making the mistake. See,
Um,
why combination?
okay.
Order will matter
Permutation.
here, right? Order will
Okay.
matter here. Okay. So
7P5.
see, anyway, we have total seven places, right? Five for numbers, two for alphabets, right? Yes or no?
yes, sir, we have that. Total
Total seven, right?
70.
In those seven places, what is the condition? There should be
That,
two numbers between two alphabets. In how many ways we can arrange two alphabets in the seven out of seven places?
sir, in that case, like just a second, it's like four. We have like four type of four possible places for the alphabets. Like
See.
if either we can place alphabet at first, second, third, or fourth position, and
Hmm.
as we put at that, we don't have like we are forced to put at it's a four at the fourth position. So we only have four possible position sets for the alpha.
Okay. And actually, my question is for total number of keys.
Okay, just
Okay.
give me a
See.
second. Let me think.
Hmm. What will be the total case where I can arrange two alphabets? It
So, but
shouldn't be 7P2,
there,
correct?
uh,
It shouldn't be 7P2 or 7 into 6. I'm talking about total case, not favorable case.
So 7P2 into 7P5.
See, you have seven places. Fine. First of all, you have to, and how many ways? Okay, what is the total case where you can arrange these two alphabets?
so for the
7P2.
sir, for the total possible cases here, that
Hmm.
is just if we consider order, that's 7 factorial. Now we have five numbers and two alphabets. For the total number of possible arrangements using
Hmm.
five numbers and two alphabets, considering
Hmm.
non-repetition, that's 7 factorial. 5 plus 2, that is a factorial. That's 7 factorial. The total number of cases.
Okay, and what about numbers should be between? Okay,
So,
one more thing. One more thing. There are something which are to be placed to next to each other.
just a second. Which are to be placed next to each other. So, this thing is a bit vague. If we consider place to each another, that means either here this question is considering a seven-digit, seven place password, or it is considering like five numbers are to be put together and two alphabets are to be put together. But in the like sub question, it says that two numbers should be between two alphabets. So that
That is
means
the main question.
yeah, so that means that we have to consider this seven means the security password is of 7 digits. That means yeah, that means the total alpha that is secure. The length of the password is 7 digits.
7 digits, that's okay. Okay, we'll just solve. Okay, I'm going to give you some 3 minutes and we'll see. Okay. So what I'm thinking, it should be some, see, anyway, we have 7 places, right? In those 7 places, I can arrange 2 alphabets.
Yeah, that's like 7 choose 2.
Correct.
No, ultimately, even if we are considering 7 factorial, now the thing is, we in this 7 factorial arrangement, we are also exhausting these 2 alphabets also. Yeah, we can also go with that 7 choose 2 and then two
Now
factorial.
7 P2 actually.
Yeah, 7p2. That is
Yeah,
7 choose
because
2 times
order
2
order
factorial.
order will matter, right?
Yeah, yeah.
Hmm. Okay, fine. Solve it. Okay, anyone? Do you need extra time limit?
Yes, sir.
1 minute? And someone was saying 7 factorial, right?
So I was saying
Okay.
like total number of cases. That's because we are considering a 7 digit password, a
Correct.
seven position password, and in which we can like add and do. So
Correct. I think it's a correct that yeah, because anyway total cases will be 7 and I have to arrange on the 7 places, so it will be 7 factorial simply 7 into 6 because you have to consider the numbers as well. Yeah, initially I was wrong actually. Uh,
actually, we can go what you did also. In that case, what we have to do is we will have to
consider for numbers again.
yeah, numbers
Means
again.
7P2 and then remaining 5 places 5P5.
Yeah, means a lot of
No,
choosing and rearrangement will do, but a bit complex when we.
yeah. Okay, so let's see the solution part. Actually, it's a 7 6. I think basically we have 7 places, right? 1 2 3 4 5 6 7. So actually we can do in 7 into 6, right? Correct. For alphabets. if you're talking about five numbers, so I can do 5 into 4 into 3 into 2 into 1, right? Yes or no? Basically, this is the total case. And favorable case, if you see, so favorable case, we have to fix, right? There should be exactly two numbers in the between two alphabets. So we have to consider the cases. So first case will be like your alphabet is on the first place and second alphabet is on the fourth place, right? And vice versa. Then there will be exactly two numbers in these two alphabets. Yes or no? Okay. So we will be having two ways. First ways for first and fourth, then fourth and first. Correct?
Yes, sir.
Are you getting this one?
Yes, sir.
Okay. Same, because see, if you want two numbers, exactly two numbers between two alphabets, the alphabets can be at this place first and this fourth place, right? Or vice versa, right? Then second place and fifth place. Then this alphabets here at fifth place and second place. Sorry, correct? Because suppose this is A, this is B. Then here should be B, then here should be A. Same third place and sixth place. And then fourth place and last. Correct?
Yes, sir. So in
So
this case, we have both
correct.
cases.
Total will be having 8 cases. So it will be 8 divided by 7 factorial. Here answer is incorrect. We'll correct it. So it will be 8 divided by 7 factorial. Fine. Is this clear now? So this is some
So can
basic.
you explain once again?
Okay, where you heard out?
So I did not get this question.
Okay, 7 factorial, you got it, right? That is total number of cases.
Yes, sir.
Now we have to see the favorable cases where exactly two numbers should be there between two alphabets. So where that two alphabets can be there, see, 1, 2, 3, 4, 5, 6, 7 places are there, right? So alphabet can be at the first place, then fourth place. Only then two numbers will be between these two, right? Yes or no?
Yes,
Or
sir.
it can be in vice versa. So there will be two ways, right? Then it can be at the second place one alphabet and at the fifth place. Then reverse order also. Again, you will be in two cases, right? Are you
Yes,
getting?
sir.
Then at the third place, then at the sixth place, right? Then here it will be again two cases, right? Then again it will be fourth place and seventh place. So there, in such a way, we'll get some 8 cases. Okay, so 8 divided by 7. Fine.
Yes, sir.
Here we have to also put the factorial of person, students, male students, five persons there. So there is a factorial of 5 person which plays in between two girls.
No. It's not about. It's just about in how many ways you can do that. It's not about that. Okay.
Okay, so we
If you see in how many ways there will be only two numbers between two alphabets. When alpha, so here our concern is about places of alphabets, right? So one way
okay.
is A. Suppose A is at the first place and B as the fourth place, right?
Yes, so that
Or
I understand. But in between two places, we have 5 options. No,
five option means
that is we have to 5 numbers and 2 alphabets, right? In a question.
yes.
So in that two place in between alphabet, we can
Hmm.
choose either two of 5, no, from 5
Okay, you
alpha.
are talking about 5C2.
Yeah.
One second. Let me question two numbers between the two alphabets.
So
Okay.
the thing is, but
Hmm.
like for 5C2, for the particular cases, we cannot proceed because there is a particular restrictions that between these two alphabets, there has to be some numbers. So we are forced to consider this for sub cases.
So then
Let's see if in first place after A we put 1 and in second place we
hmm,
put 3
hmm.
and in the last 3 places 3, 4, 5. Then we interchange with 2, 1, 3, 4, 5, 3, 1, 4. 2, 5, like that.
They didn't mention about the placing of numbers
Fine, fine.
in order.
Okay. I think, yeah, that might be mistake. I think actually it's also we have to. I mean, these things we have to. There, I mean, there is need to mention clearly. Okay. Don't. I got it. I think there is ambiguity in this question, right? That misconception. Yeah. Okay, don't worry.
Sir,
So
I have done the that
yeah.
I'm saying I have done the same thing. Then I
Hmm.
got the answer 0.19.
Okay. No, 0.19 you are getting by 5C2 you are doing. Then you have done
Yeah,
5C2 into 2, correct?
yeah,
Plus
yeah. Into
the
4,
same thing
four
into
ways
4.
for the yeah,
So
alphabets.
means
Yes,
basically you have done 8 into 5C2, right?
yes,
Divided
yes.
by 7 factorial.
Yeah.
Okay, let's do this like this. So 5 factorial, 2 factorial, 3 factorial, 8. Then 5, 4, 3, 5, 2, 7, 6, 5. Basically 5 factorial. Okay, let me basically 5 factorial, 3 factorial, 2 factorial divided by 7, right? So that simply means let's do like this. So if you see here, so this is 8 into 5 into let's make it 5 factorial. So it's a 3 into 2 into 2, right? And this is nothing but again 1 by 7, 7 into 6 into 5. So 5 will get cancelled out, right? And
Mhm.
this is 7, 6, and this is 4, 2. I'm making mistake, I think.
Sir, I have what I have done now.
Hmm.
And after first alphabet, I put there 5 choices we have. No, so
Correct,
I
correct.
multiplied 4 into 2 into 5. Then for
Hmm.
second place, we have 4 choices for numerical. So I multiplied it with 4. Then for last 3 places, I put 3 factorial.
Okay, so you mean 1, 2, 3, 4. A is here, B is here, right? You mean
Yes,
5 into 4 and remaining
or
3.
remaining 3. Yeah.
I don't think this is the situation where we need to worry. Anyway, we'll see. Don't worry. We'll correct. I think it should be 5, 6. Okay, I will cross check with this question. Okay, then we'll correct it, and then after that we'll upload on the portal. Fine. Okay, I think
Okay.
there is that mistake also, that 7 factorial. Okay, so there is this is some extra question. Okay, just think 30 seconds will be more than enough. One second. Yeah. Okay, 4 people are option A and 2 are 2. Okay. Okay, those who are still confused with this, try to solve the more questions. Okay, so this is the last slides. Okay, anything, any doubt? I think someone
Sir,
asked me
I
that
have,
tutorial, right?
yeah, tutorial 4 and tutorial 7, please.
Tutorial 4, right?
Yeah.
Let me see what is that. Let me see the question. So what is doubt in tutorial 4?
So the like I have like it when we consider that Mary is one of these 1,000 students now,
Hmm.
so that is like what that is Mary is going to be like equal count in the proportion of that is we choose that 30,000 choose 1,000, yeah, that should be the proportion in how much
Okay, one
uh,
second.
combinations the Mary has
Que-
repeated.
Question is saying 30,000 students join the IITM online degree course for data science. Fine. IITM online degree send a feedback form to 1,000 randomly selected students. Mary and Asad had joined this course. Fine. What is the problem? Mary got the feedback form and Asad did not get a feedback form. It's a clear, right? See, uh, it's a simple thing. Suppose I'm saying Mary got the feedback form. So Mary will come under the 1,000, right? There is no need to select 1,000. Are you getting? Suppose I'm saying, okay, what is the probability that feedback form will send to the students?
Probability of means one thing like
Hmm.
like what I understood from this question is
Mm-hmm.
first we have chosen 30,000 that is first we have performed initially before this question was
Mm-hmm.
framed
Hmm.
that we have a case of 30,000 choose 1,000
Hmm.
of this cases we have choose a particular case that has 1,000 randomly selected students, yeah.
Okay, you mean it should be 30,000 C 1,000 and numerator pass would be 1,000, right? 1,000
No, no,
C1.
no, no, no.
Hmm.
What I am saying is, sir,
Hmm.
we know that for any type of arrangement or combination,
Hmm.
a particular element repeats equally. Means if I say that I have three elements A, B, and C, and I make a combination of two
Hmm.
that is a three choose two,
3 choose
then
2,
I
correct.
know, yeah, then I know that how much time A is going to repeat, it's going to be the same as how much time B is going to repeat, and that is also going to be same as how much time C is going to repeat in this number of combination. And
Okay.
that is going to be the fraction that is like number of elements that is three.
Hmm.
Uh,
So you mean it should be 30,000 C 1,000, right? Denominator part.
30,000 choose 1,000
Hmm.
uh, means it's going to be one like we have 30,000 students now, so it's
Mm-hmm.
going to be like 30,000 choose 1,000 whole divided by 30,000. That is like probability of Mary being in that particular case, particular 1,000 students.
Okay. So 30,000 students join this program.
That is numerator I'm saying 30,000 choose 1,000. And in that case, I know that the total number of students are 30,000. Each student repeats equal number of time, and number of students is like 30,000. Therefore, all complete 30,000 choose 1,000 divided by 30,000. That should be the case when I have Mary in my case. How
Okay,
much?
okay. Simply, I mean, you mean, I mean, total 30,000 students is there, right? You are saying Mary got the form. That means Mary in out of those 1,000 students, right? Mary
Yeah,
belongs to that. So
yeah.
you mean 30,000 C 1,000, correct?
Yeah, 30,000 C 1,000 whole divided by 30,000. That is the
Yes.
number of cases this 1,000 randomly selected cases will have Mary in them.
Okay, fine, fine. I got your point. Okay, don't worry. I think yeah, will okay. Then we need to change this solution video itself. Fine, fine. Okay, don't worry, Ankit. Ankit, right?
Yeah, yeah.
I will cross check with the team again, and they will upload the correct solution. Okay? I think your point is okay, but I think it should be clearly mentioned, right? I think there is a statement missing also. Statement missing means there should be something. It's clearly mentioned. We are going to select 1,000 random students randomly out of 30,000, right?
So this is
Hmm.
already done. Like they have sent the like form to 1,000
Form,
student.
yeah, yeah. They have said, no,
No,
no. What I mean, it should be like 30,000 students are there, right? It should be
yeah.
like we are going to select 1,000 randomly students and we are going to send a form to those 1,000 students. I mean, the question framing of the question should be like this, right? Then it's clearly it should be 30
And
thousand choose 10.
sir, in this particular question, from
Hmm.
the question, same question that we taught today, from the set theory perspective, there's union, intersection, all things.
Hmm. Hmm.
So
Hmm.
if there's a different approach with the statement that is given, like in this question, that
Hmm.
is, if I consider 30,000 choose 1,000, okay,
Hmm. Hmm.
I will have all the possible number of count of the number of possible this combinations that are possible. Yeah,
Yes, but you have to
if,
multiply with I think 1,000 also because
if
that Mary is out of those 1,000, right?
Mary is going to be out of 1,000, that is going to be divided by 30,000 of this choose. Why? Because I know that whatever combination I make, a particular
Mm-hmm.
element will have the equal number of repetition, means the proportion of repetition of single element in all the combination will be constant.
Correct.
So regarding that, now if I say that number of combination that will have Mary in it, that
Mm-hmm.
will be 30,000 choose 1,000 divided by 30,000. And it forms a set. It's like Mary, a circle.
Mm-hmm.
Yeah, and that value that what are the number of combinations that is going to be this. Now same we can proceed for Asad, and then
Asad, yes.
that yeah, so that should be like approach, but directly dividing 1,000 by 30,000 becomes like no direct logic I see
Okay,
there.
okay. Don't worry. I will check with the team and will upload the correct solution video. Okay. Thanks for the correction. Okay.
Okay,
I
sir.
think it's a
Sir,
good point because I am getting your point. It should be some because first of all I need to choose those 1,000. Like I mean out of 30,000, right? You
So
mean that?
even
Hmm.
if I am not choosing this 1,000 now, I will still have to consider that how much 1,000 these cases are, how
Correct,
much
correct,
combinations are of 1,000 students that have marinate.
correct, correct, correct.
And so could you explain the approach for question number 7 also? Like I didn't exactly like I was having a bit doubt. Should I means how should I proceed in this solving this seventh question?
So what is the doubt? Tutorial 7 you mean, right?
Yeah, tutorial 7.
So this is question, an engineering college hostel has 20 rooms. This question, right? You're talking.
Yeah, 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 yeah.
Okay, so containing two beds per room, fine. 20 civil engineering students and 20 computer science students are allotted to these rooms, fine. If the pairing is done at random, what is the probability there is no civil and computer engineer roommate pair? Fine, fine. Okay. Okay, so this total case is clear or not? So see, if you
So,
see, hmm,
hmm,
yeah,
yeah,
if you
please
see
go
the
ahead.
total case, if you see the total case, I think this solution is made by previous instructors. No problem. Okay, see, I have total 20 rooms, right?
Yeah,
Correct? 20 rooms.
yeah.
So
Hmm.
two rooms per bed. That means 40 beds. Okay, let me
Yeah.
share my screen.
So in this question, like
Hmm.
what my thought is, let me explain and please guide me that. What
Okay.
I said that I have 20 rooms, yeah.
Hmm.
To satisfy this particular condition, I can only choose first if I choose 10 rooms.
Hmm.
That is 20 choose 10.
Okay.
I will have 10 rooms.
Then fine.
In this
Hmm.
10 rooms, I am free to choose two students per room or from each segment.
Okay. You're talking about this case, right?
Hmm. 20 choose 10. Just a second. I did 20 choose 10. But what's with
No.
this?
Ah, see the clearly, right? If you see the little bit.
For this solution, I didn't for this question, I didn't went through this solution. Because what so I was choosing from first like 40 choose 2, then
Hmm.
30 choose 2.
Hmm.
So I differ, like my approach differed. That's why I asked you. That is what I thought. Why don't I choose 10 rooms first? That is 20 choose 10. I have my 10 rooms. Yeah. For a
Okay.
particular room,
Hmm.
I can choose like 20 choose 2, then 18 choose 2. Yeah. Up to 2 choose 2. Now
Fine.
again, I have done this. Now again, I will have to go with 20 choose 2, 18 choose 2, and so
Hmm.
on. Yeah.
Okay. Fine. So what about total case? That is something you are doing the okay. See, first of all, you're choosing the 10 rooms, right? Suppose this 10 is for civil, right? And civil, and what are the two departments?
It's civil and
Computer.
computer.
So if you see, let's say ten rooms are for civil, right?
Yeah.
And then 10 for the computer, correct?
Yeah. Mm.
So if you see, you are choosing 20 C10. That is something you have done, right?
Yeah.
Then in that 20 C10, now tell me in how many you can arrange the 20 people?
So, is this 20 factorial same as saying that 20 choose 2 times 18 choose 2 and this series? Is this equivalent to 20 factorial?
20 factorial not equivalent to choose 2. 20 factorial is equivalent to 20 into 19 into 18.
No, no,
Hmm.
I'm talking about series. That it's 20 choose 2 times
Hmm.
18 choose 2 times
Hmm.
16 choose 2 up to 2 choose 2. Is it equivalent to 20 factorial?
You can cross check. I don't understand.
Because I think if they are equivalent, then
No, see,
both of
in
them.
either way, right? In either way, you will get the correct answer.
20 choose
Okay.
2.
So it will be 2 factorial always. If
Yeah.
you do 18 choose 2, 2 factorial will be there, 16 will get cancel out. Okay. So
Mhm.
yeah, that is the
Yeah,
same
yeah.
thing, guys. Okay, because anyway you will get 2 factorial is power 10.
Mm-hmm.
Okay, as you can see here,
Yeah, yeah.
correct?
Mm-hmm.
Are you getting? So again, you
Yeah,
will
yeah.
get for 17 choose 2, that means 17 into 16 divided by 2 factorial into 15 factorial, 15 factorial. This will get cancel out.
Mm-hmm. Okay. So my
No, I
answer
think
is
it shouldn't be 18, it should be 16.
yeah, yeah,
16,
16.
16 choose 2.
16 choose
Then
2.
16 into 15. Okay. Then
Mm-hmm.
2 factorial, the same thing here, it has been done, right?
So, what's the logic? But here the denominator, but total number of cases. Yeah, that is okay. What's about this 2 to
Hmm?
the power 10? Why he have like done here for this case?
See, first of all, I have chosen 10 rooms, right? 20 C10, correct?
Yeah.
Then for first 10 rooms, I can do in 20 factorial divided by 2 raised power 10.
Why 2 to the power 10? 20
Or, okay,
factorial.
okay. Anyway, this is same as 20
Yeah, yeah,
C10
yeah.
actually.
Yeah. Got it,
Okay.
got it, got it.
See,
Because the inherent order is not there. That
correct, correct. Suppose
all the two guys
220
that.
C10, right?
Yeah,
Then
yeah, yeah.
Then for 10 civil rooms, so I will do 20 C2 up to 2 C2, right?
Yeah.
Again,
Got
for 10
it
CS,
now.
we'll do, correct? The
Yeah,
same
yeah.
for the,
Got
got
now,
it?
sir. Got
Yeah,
it, sir.
yeah.
Thanks.
That's all.
But
Then
that
for
that
tutorial 4, we'll check, we'll cross, I will solve it again. And if there will be correction and all, we'll do the correction and we'll re-record and we'll upload, okay? Fine. And thanks for that
okay,
pointing
sir.
out that
So
correction.
what?
Hmm.
Okay. So one small like conceptual thing,
Hmm.
when we are having non-simultaneous thing, yeah, or we say like I have to talk about a combination
Hmm.
that I have to choose. Like
Hmm.
say I have to choose two students out of 10 students. That is
Hmm.
10 choose two.
Hmm.
In this case, I am making collective means I am making a decision collectively.
Hmm.
So in this case, should I consider this as simultaneous case or
Yes,
non-simultaneous?
why not? See, basic thing is simultaneous basically means here, suppose I'm doing one after the other. For example, if I have to create a password of 4 digits, okay? Then
Yeah.
to create a password of 4 digits, suppose with the help of some, let's say, with number 0 to 9.
So permutation thing is clear, but
No,
in
no,
the
I will
combination,
come to that one. Don't. Let me
okay.
finish what is the meaning of simultaneous. Simultaneous is I have to fill for the first digit, then second digit, for third digit, and fourth digit, right? So it
Yes,
will be
sir.
first and for the second and for the third and for the fourth. Means I have to create password of 4 digits simultaneously, right? I have to fill
Mm.
all four digits, right? Correct? Then
Yeah.
this is something simultaneous. If I suppose
Mm.
there are four people in a room, I want to choose two people, correct? So I will choose
Yeah.
two people simultaneously. Let's say choosing A, B, or B or A. So I'm choosing simultaneous. Okay. This basically I have to choose these two persons, A and B or B and A. So this is simultaneous. Okay.
Mm.
So only difference is permutation combination is order matters in case of permutation, and order doesn't matter in case of combination. For example,
Okay.
suppose I'm going to choose two people, right? So I can choose
Mm.
A or B, or another set B or A. So anyway, I selected these two people, right? These two possibilities same, right? So I can do
Yes,
in
sir.
4C2 ways, right?
Mm.
If you okay, so this here order doesn't matter. If you see, suppose I'm saying A is the captain, means, and B is the vice captain. And again, suppose I'm saying A is the vice captain and B is the captain. So does this order and this order is same? This AB and this AB is same?
No, sir.
They're different. They are different.
They are different, right? Here, that means order matters, correct? So
Yeah,
what we
yeah.
have done here, if you see, oh, okay, first of what we have done, I have selected these two people out of four, yes or no? After that, I
Yes,
have
sir.
arranged these two in two factorial ways, which is nothing but 4p2 actually.
Yeah.
So why this 4p2 came? Because of these two factors. Means here we are order matters. If order doesn't matter, I if I need to select it, then there is just need to select two people. I will go with the combination. Is this clear?
So my
Hmm.
previous thought on the case of simultaneous was that
Hmm.
when I'm standing on a particular block, like you
Hmm.
made this four blanks now.
Hmm.
So my previous thought for simultaneous was that when I am sitting at the first place, I am only deciding what type of first, how much possibilities are there, what kind of numbers are there that can go in the first place.
Hmm.
Then, when I move to the second place,
Hmm.
then I consider what type of elements are there that can come in the second place. That is what
Hmm.
my thought simultaneous thing
Ah,
was.
correct. Because see, for whole thing, suppose there are two chairs, okay, and you
Yeah.
have 10 people. Then
Hmm.
first chair you can sit any nine. Then for second chair, basically we have to consider both. Filling for both chairs simultaneously. That means.
Yeah, but when we consider the picture of this combination thing, that is like four choose two,
Hmm.
in that case, I am deciding on this number, this element that I'm going to set, but disregarding the order.
Yeah, disregarding the order, that's fine, right? See, anyway, suppose okay, disregarding the order means what? Suppose you have selected A first, then B, right? Anyway,
Yeah.
you have selected A and B, correct?
Hmm.
You have done both, right? A and B.
Hmm.
In other way, suppose you have selected B and then A. Again, you have a combination of A and B, right?
So it does not matter that
No,
but
position doesn't matter actually. Okay, if position will
okay.
matter, simultaneous is there, right? Two, you are doing simultaneously. But if you are doing A and B or B and A and without worrying about order, then it will be combination part, right? If you are
Yeah.
mentioning the position, suppose one is captain, one another vice captain or president, vice president, then it will be the permutation. That two
Okay.
factorial it will be there.
Mm. But in cases, in a question when we have cases
Hmm.
that is O, that is we have to use the addition rule, then that case it is not a simultaneous thing.
Yeah.
So if
Intersection
I
is
consider,
intersection is simultaneous.
if I consider, yeah, intersection is simultaneous,
So basic
or
thing,
that is O, that is addition
or is
non-simultaneous.
non-simultaneous and is simultaneous. Correct.
Yeah. So in that case, if I am giving a question that rearrange the numbers
Hmm.
0, 1, 2, 3 to
Hmm.
form a three-digit number, okay?
Hmm.
In this case, I
Hmm.
have to choose non-simultaneous thing because 0 is a particular case, and I have two subcases. One when 0 is not in the first place, and one in which 0 is
No, no,
Please.
no. It's not about 110, 101. To fill that three positions, you have to do the you have to fill the position simultaneously. You have to fill for the first, and then after the second, and after then for the third place. Just think like that. Okay. See here we are doing. See.
Yeah, yeah.
Okay.
Got it.
Suppose I have to create a four-digit password. Okay. That means I have to do. Okay. So see the steps. I mean here, don't go with the basic meaning of simultaneous. What does here mean? Here, suppose I'm doing the selection of digits simultaneously. So selection of digits simultaneously means to create that password. I have to create four-digit password. The selection of four digits will be simultaneous. Means for the first digit, then for the second digit, then for the third, then for the fourth. That is the meaning of fair. Okay, don't go with the literal meaning of simultaneous. Fine. Same, suppose you have to select four people for four chairs, something like that. Then you have to select people for first chair and for the second chair and then for the third chair, then for the fourth chair. Anyway, you have to fill all the four chairs. That is the meaning. Got it?
Okay, okay.
Yeah.
So, like, what I was thinking, like, we have one question in EMQ.
Mm-hmm.
In that case, like, I have to decide on the pattern A or pattern B. And
Then
when
it
we are,
will be or.
yeah, then it is or,
Or,
and
yeah.
in that case, this is a simultaneous
Inside A,
event.
it will be simultaneous.
Yeah, inside it will be simultaneous when we are
Simultaneous.
considering inside pattern A or pattern B.
Correct.
Now, what I am linking the same idea with the number arrangement, that is when I am giving the number 0, 1, 2, 3.
Mm-hmm.
Yeah. Now, when I consider this type of case, I consider that 0 cannot come in the first place.
It
No,
will
no,
depend
no,
on
no,
the.
no, sir. I will like it. I need a bit more thought. I will give a more
Mm-hmm.
thought, and then it will better that I express it more comprehensively.
Yeah, go
I
ahead.
I need to like when we are
See,
considering.
you mean zero shouldn't be at the first place, right?
No,
So,
I'm
mm,
saying when in any question we are forced to consider sub cases that are in the form of or, that is
mm,
we are forced to consider the addition rule.
then see, if you're talking about, suppose there are two kind of password, password A, password B, password C, right?
Yeah,
Then it will be non-simultaneous because I'm asking about A or pattern B or pattern C, right?
yeah.
If
Mm,
I'm saying inside A, suppose A is four-digit password, then it will be simultaneous.
mm,
Inside B, it's simultaneous. I mean, it will be clearly mentioned whether you have to select the step for inside A or throughout the thing. Okay. If it's clearly mentioned for inside A, I mean, to suppose I'm saying to what will be the steps to create the password of pattern A. So whatever pattern A is there to create that password, it will be simultaneous. Fine. If I'm saying for
yeah.
password pattern B, it will be again simultaneous. If I'm saying I have to choose pattern A or pattern B, then it will be non-simultaneous. Means either I can choose A or I can choose B. I'm not going inside A, inside B. I'm just going with the selection of either A or B. Right? It's a non-simultaneous for selection of A or B. Getting?
Yes, sir.
Means I
Yeah.
can't select B if it's A. I can't select A if it's B.
Yeah. So
Fine.
could you write a question like now I have like a
Hmm.
question in mind, particular question.
Can okay. So
Yeah, like I
hmm,
have
hmm,
numbers 0, 1, 2, 3, 4.
hmm,
Now I have to count the total number of what are the total number of even number possibles without repetition for this particular case. Okay.
hmm,
So in that case, I am forced to decide on sub cases. One sub case is when 0 is at the rightmost position. That is one case.
see.
Yes, second case is when I have 2 or 4 in the last position.
That's fine.
So I
So hmm, okay, that's okay.
either it's when
Yeah.
yeah,
When you want to select your steps, that's tell me.
yeah. So in that case either I choose when 0 is at the last position, or
Hmm,
I choose when 0 is not at the last position. That is 2 4 is at the last position. So I have two sub cases, and the result is going to be the addition that I am forced to make a choice
See, first
between
of
the.
all, you are not listening me carefully. What I told you, suppose that pattern A, suppose zero is at the last, okay?
Yeah,
For inside pattern, it will be simultaneous or not?
yeah, inside it will be simultaneous.
Suppose there is B at last, suppose this is 4. For B, it
Yeah,
will be simultaneous, right?
yeah,
If you want to choose either or A, suppose I'm saying what select the appropriate stage for the selection of pattern A or pattern B, then it will be non-simultaneous. I'm
yeah,
not going
sir.
inside A, side B. I'm
Yeah,
going
yeah,
for either A or B. Fine.
yeah.
Whether you
That.
want to choose 0, 4 or not, doesn't matter. Okay.
Yeah, yes, sir. But sir, the same thing was I was saying. I was
Hmm.
only saying like just right. If I am giving you 0 1 3 4 numbers,
Hmm.
0 1 3 4 numbers.
Hmm.
Now I am saying that for what is the total number of even number 3-digit even number possible using these numbers without
Hmm.
repeating. In
Hmm.
this case, I am forced to consider this case that is A or B case that you have written. So
Hmm.
in that case, when I'm considering the total number of even number of cases that are possible using 0 3 4, in
Hmm.
that case, it is going to be non-simultaneous thing. But when I go to a particular case that is either zero is at the rightmost position
Then it will be
or it is a
non-simultaneous.
four, yeah, non-simultaneous.
Huh.
So this thing I was confirming that to differentiate that when we are
Yeah.
considering three-digit even number, then it's going to be non-simultaneous thing.
Three-digit even number. Why?
No, like you already written. Either it's going to be the zero on the rightmost position,
Hmm.
or it's going to be the four at the rightmost position.
If you are
So
differentiating that case separately, right? 0 or 4, then it will be non-simultaneous. If you are
yeah,
go with zero case or fourth case, then it will be simultaneous.
yeah.
For separately. Yeah.
But when we are considering all the count of all the even numbers, three-digit even numbers that are possible using 0 1 3 4, then that's going to be non-simultaneous case.
See, no, no, no. It's not about that. See, in that case, even though that three digit we have to consider, right?
Yeah, we have to consider, but
We have to
that is equivalent to saying that choose a pattern A or pattern B.
see
What
anyway. No, no, I'm not saying no, no. It will be clearly mentioned whether you have to choose pattern A or pattern B, right? So I'm simply saying I have to create a password of three digit, right? It should be even number. That means I have to see then it will be clearly mentioned whether you have to go with zero or four, right? Anyway, for this case, I have to select these things and these things for the second and for the third, right?
So when question
Hmm.
mentions that it has to be the even number, so I am forced to consider that only it's 0 or 4 that can come at the rightmost position.
That's okay. But for this case, to create the password, it will be simultaneous. For
Yeah,
different cases, it will be non-simultaneous. If you are
non-simultaneous.
interested, it's a count or total, then it will be non-simultaneous.
Yeah.
Right? Yeah.
So just confirm me that if we are considering the all the possible number count of number of all the even number possibles using 0 1 3 4,
Hmm.
then is it going to be simultaneous or non-simultaneous?
It, first of all,
Because
statement should be clear whether we have to consider all the pattern or inside a pattern. Okay. If
okay, means in that
you can't generalize first of all.
okay,
Generalize.
if a question will be framed, then they will mention this thing
Correct.
explicitly.
Huh? That's why we are mentioning, right? You can see the MQ questions of week 5 and week 6.
Yeah,
Okay.
yeah. Then I don't need to dive into it because I was driving it.
No, no,
Sometimes
no, no.
question it's not mentioned, but we are forced to consider this or conditions.
No, no,
That is
no, no, no. It's not like that. It will be clearly mentioned.
okay. Then
Yeah.
that's fine.
Okay. Yeah.
Yeah.
Is that all right?
Yes, sir. Thank you
Yeah.
for this answer.
Oh, thanks. Thanks. No problem. Yeah.
Okay, thanks.
Okay. Bye. Thanks.
Bye. Bye, sir.